Space and Science News. With James. In the vast expanse of our solar system, a frozen world holds secrets that could change everything we know about life in the universe. Europa, a moon of Jupiter, may seem like just another icy rock orbiting a distant planet. But beneath its cracked and scarred surface lies a tantalizing possibility, an ocean of liquid water, hidden from view, potentially teeming with alien life. Today, we'll be talking about NASA's Europa Clipper mission because why not explore one of the most intriguing places in our cosmic neighborhood? This ambitious spacecraft is about to embark on a journey that will take it nearly 1.8 billion miles from Earth, all to unravel the mysteries of this enigmatic moon. But here's the thing, Europa isn't just any moon. It's a world of extremes, where the surface temperature plummets to minus 260 degrees Fahrenheit, and Jupiter's intense radiation could fry most spacecraft in minutes. So how will Europa Clipper survive this hostile environment long enough to unlock Europa's secrets? And what might we find lurking in those alien waters? Let's dive deep into this extraordinary mission to Europa and discover what it could mean for the search for life beyond Earth. In the vast expanse of our solar system, a frozen moon orbits the gas giant Jupiter. This icy world, known as Europa, has captivated scientists for decades with its potential to harbor life beyond Earth. Beneath its cracked and scarred surface lies a secret, an ocean of liquid water, hidden from view but teeming with possibility. Now, NASA has embarked on an ambitious mission to unlock the mysteries of this alien world. The Europa Clipper spacecraft, launched on October 14, 2024, is on a journey that will take it nearly 1.8 billion miles to reach its target. This mission represents the culmination of years of planning, research, and technological innovation, all aimed at answering one of the most profound questions in science: could life exist in Europa's hidden ocean? Europa's allure stems from its unique characteristics. Despite its frigid surface temperatures, which plummet to minus 260 degrees Fahrenheit, evidence suggests that beneath its icy crust lies a global ocean of liquid water. This ocean is believed to be kept warm by tidal heating, a process caused by Jupiter's immense gravitational pull. The presence of liquid water, combined with potential energy sources and organic compounds, makes Europa one of the most promising places in our solar system to search for extraterrestrial life. The Europa Clipper mission faces numerous challenges. The spacecraft must navigate the intense radiation environment around Jupiter, which could easily damage sensitive electronics. To combat this, engineers have designed a unique radiation vault to house the spacecraft's most critical components. Additionally, the mission's orbit around Jupiter has been carefully calculated to minimize radiation exposure while maximizing scientific return. As Europa Clipper embarks on its long journey, it carries with it the hopes and dreams of scientists and explorers worldwide. The mission's findings could revolutionize our understanding of habitability in the cosmos and potentially answer one of humanity's most enduring questions: are we alone in the universe? By studying Europa's composition, geology, and the nature of its subsurface ocean, Europa Clipper aims to provide crucial insights into the potential for life beyond our planet. The Europa Clipper's journey began with a spectacular launch from NASA's Kennedy Space Center in Florida on October 14, 2024. Perched atop a powerful SpaceX Falcon Heavy rocket, the spacecraft thundered into the sky at 12:06 p.m. Eastern Daylight Time, leaving behind a trail of fire and smoke as it escaped Earth's gravity. This marked the beginning of an epic voyage that will span nearly 6 years and cover a distance equivalent to traveling around the Earth more than 72,000 times. The launch itself was a testament to human ingenuity and perseverance. The Falcon Heavy, with its 27 first-stage Merlin engines roaring to life, provided the immense thrust needed to propel the Europa Clipper on its interplanetary trajectory. The rocket's two side boosters separated approximately 3 minutes into flight, followed by the central core a minute later. This carefully choreographed sequence ensured that every ounce of fuel was utilized to give the spacecraft the velocity it needed to break free from Earth's gravitational pull. As the Europa Clipper hurtles through space, it will employ a clever technique known as gravity assists to conserve fuel and increase its speed. The spacecraft will first swing by Mars, using the red planet's gravity to slingshot itself back towards Earth. This cosmic dance will continue as it performs another gravity assist with our home planet, finally gaining enough velocity to make the long trek to Jupiter. These maneuvers are crucial for the mission's success, as they allow the spacecraft to reach its distant target without carrying an impractical amount of fuel. During its interplanetary cruise, the Europa Clipper won't be idle. Scientists and engineers will be constantly monitoring the spacecraft's health, performing course corrections, and calibrating its sensitive instruments. This period also provides an opportunity to test the spacecraft systems and ensure everything is functioning perfectly for the critical mission ahead. The team will be particularly focused on the spacecraft's massive solar arrays, which span nearly 100 feet, 30 meters, when fully deployed. These arrays, the largest ever flown on a planetary mission, are essential for generating power in the dim sunlight of the outer solar system. As it approaches Jupiter in April 2030, the Europa Clipper will face one of its greatest challenges, navigating the intense radiation environment surrounding the gas giant. Jupiter's powerful magnetic field accelerates charged particles to incredible speeds, creating a hazardous zone that could easily fry the spacecraft's delicate electronics. To protect against this, the mission team has encased the most sensitive components in a vault-like structure, shielding them from the worst of Jupiter's radioactive assault. This innovative design, coupled with a carefully planned orbit, will allow the spacecraft to conduct its scientific investigations while minimizing exposure to the harsh Jovian environment. Once safely in orbit around Jupiter, the Europa Clipper will begin its intricate dance with Europa, performing a series of carefully choreographed flybys. Each pass will bring the spacecraft tantalizingly close to the icy moon's surface, allowing its suite of instruments to peer beneath the frozen exterior and unlock the secrets hidden within. The mission is scheduled to perform at least 49 close flybys, with some passes bringing the spacecraft as close as 16 miles, 25 kilometers, above Europa's surface. This proximity will enable unprecedented observations of the moon's geology, composition, and potential habitability. The journey of the Europa Clipper represents a culmination of years of planning, technological innovation, and scientific curiosity. As it embarks on its long voyage to the Jupiter system, it carries with it the hopes and dreams of countless scientists, engineers, and space enthusiasts eager to unravel the mysteries of one of the solar system's most intriguing worlds. As the Europa Clipper settles into its orbit around Jupiter, the real scientific detective work begins. The spacecraft is equipped with a suite of 9 cutting-edge instruments, each designed to reveal different aspects of Europa's nature and potential habitability. This ambitious mission represents a quantum leap in our ability to study one of the most intriguing worlds in our solar system. One of the primary objectives is to confirm the presence and extent of Europa's subsurface ocean. While previous missions have provided strong evidence for its existence, the Europa Clipper will use its magnetometer to measure the moon's induced magnetic field with unprecedented precision. This instrument, known as the Europa Clipper magnetometer, ECM, consists of 3 magnetic flux gates placed along an 8-meter boom. By studying the strength and orientation of Europa's magnetic field over multiple flybys, scientists hope to determine the ocean's depth, salinity, and even its global distribution beneath the icy crust. The spacecraft's ice-penetrating radar, called Radar for Europa Assessment and Sounding, Ocean to Near Surface, REASON, will peer beneath Europa's frozen surface. This instrument will map the thickness of the ice shell, potentially revealing the presence of subsurface lakes or channels. REASON operates by sending radio waves through the ice and analyzing the reflections, providing crucial information about the structure of Europa's icy shell. This data is vital for understanding how material might be exchanged between the surface and the ocean below, a key factor in assessing the moon's potential for supporting life. Europa Clipper's imaging system, the Europa Imaging System, EIS, consists of a wide-angle camera and a narrow-angle camera. These cameras will capture high-resolution images of the moon's surface, revealing details as small as 50 centimeters across. These images will help scientists identify areas of recent geological activity, such as cryovolcanoes or regions where the ice shell may be thinner. The EIS will also be crucial in studying Europa's surface features, including the mysterious, chaos terrain that suggests complex interactions between the surface and subsurface. The spacecraft spectrometers will analyze the chemical composition of Europa's surface in unprecedented detail. The Mapping Imaging Spectrometer for Europa, MICE, will create detailed maps of the distribution of organic molecules, salts, and other materials across Europa's surface. This information is crucial for identifying potential landing sites for future missions and understanding the chemical processes occurring on the moon. One of the most exciting possibilities is the chance to sample Europa's ocean directly. Previous observations have hinted at the presence of water plumes erupting from cracks in the ice. If these plumes are active during the mission, Europa Clipper's mass spectrometer, the mass spectrometer for planetary exploration /Europa, MASSPEX, could fly through them. MASSPEX is designed to analyze the composition of gases with extremely high sensitivity, potentially detecting complex organic molecules or other biosignatures that could indicate the presence of life. The spacecraft will also study Europa's tenuous atmosphere using the Europa Ultraviolet Spectrograph, Europa UVS. This instrument will investigate the composition of the atmosphere and how it interacts with Jupiter's intense radiation environment. By studying the gases escaping from Europa, scientists hope to gain insights into the processes occurring on the surface and potentially in the ocean below. Throughout its mission, Europa Clipper will perform at least 49 close flybys of the Moon, each time diving into the intense radiation zone around Jupiter before retreating to safer distances to transmit its precious data back to Earth. This hit-and-run strategy allows the spacecraft to maximize its scientific return while minimizing exposure to the harsh Jovian environment. The Plasma Instrument for Magnetic Sounding, PIMS, will play a crucial role during these flybys, measuring the density, temperature, and flow of charged particles around Europa to help understand how the Moon interacts with Jupiter's magnetic field. As the data streams back to Earth, scientists will begin the painstaking process of piecing together the puzzle of Europa's potential habitability. They'll be looking for evidence of energy sources that could support life, such as hydrothermal vents on the ocean floor or chemical reactions driven by radiation at the surface. The Surface Dust Analyzer, SUDA, will contribute to this effort by studying the composition of dust particles around Europa, potentially providing clues about the chemistry of the subsurface ocean. While Europa Clipper isn't designed to directly detect life, it will provide the most comprehensive assessment yet of whether this distant moon could harbor the conditions necessary for life as we know it. The mission's findings will help shape our understanding of the potential for life in the outer solar system and beyond, potentially revolutionizing our view of our place in the cosmos. By combining data from all 9 instruments, scientists hope to build a holistic picture of Europa's environment, from its deep ocean to its icy surface and tenuous atmosphere, unlocking the secrets of this fascinating world and paving the way for future exploration. Exploring Europa presents a unique set of challenges that have pushed the boundaries of spacecraft design and mission planning. The harsh radiation environment around Jupiter is perhaps the most significant obstacle. At its peak, the radiation levels near Europa are thousands of times more intense than what we experience on Earth. To protect the sensitive electronics aboard Europa Clipper, engineers have developed a unique radiation vault, a 150-kilogram titanium box that houses the spacecraft's most critical components. The extreme cold of the outer solar system poses another challenge. At Jupiter's distance from the Sun, solar panels are much less effective than they are near Earth. To compensate, Europa Clipper is equipped with massive solar arrays spanning nearly 100 feet, 30 meters, when fully deployed. These arrays, the largest ever flown on a planetary mission, will generate about 600 watts of power, equivalent to running a household blender. Communication with the spacecraft presents its own set of difficulties. At its farthest point from Earth, radio signals from Europa Clipper will take nearly an hour to reach us. This means that the spacecraft must be largely autonomous, capable of making decisions and adjusting its operations without real-time input from mission control. The mission's unique orbit around Jupiter, designed to minimize radiation exposure while maximizing scientific return, required innovative trajectory planning. Engineers use sophisticated computer models to plot a course that allows Europa Clipper to perform its close flybys of Europa while spending most of its time in safer regions of space. Data management is another crucial aspect of the mission. With its suite of instruments collecting vast amounts of information during each flyby, Europa Clipper needs to efficiently store, process, and transmit this data back to Earth. Advanced onboard computers and data compression techniques have been implemented to handle this flood of scientific information. Perhaps one of the most exciting innovations is the potential for Europa Clipper to detect and sample water plumes erupting from Europa's surface. The spacecraft's instruments are designed to operate at incredibly high speeds, capable of analyzing particles as the spacecraft zips through a plume at over 15,000 miles per hour. These technological advancements not only enable the Europa Clipper mission but also pave the way for future exploration of the outer solar system. The lessons learned and technologies developed for this mission will inform the design of spacecraft for generations to come. While Europa Clipper is not designed to directly detect life, its findings will have profound implications for our understanding of the potential for life beyond Earth. If the mission confirms the presence of a global subsurface ocean, organic compounds, and energy sources on Europa, it would significantly bolster the case for the Moon as a potentially habitable world. Such a discovery would likely spark a new era of exploration focused on the icy moons of the outer solar system. Already, plans are being discussed for follow-up missions that could more directly search for signs of life on Europa. One concept involves a lander that could touch down on the icy surface, drill through the crust, and sample the ocean directly. Even more ambitious proposals include a submarine-like probe that could melt its way through Europa's ice shell and explore the alien ocean beneath. While such missions are still in the realm of science fiction, the data from Europa Clipper will be crucial in determining their feasibility and design. The implications of Europa Clipper's mission extend far beyond our solar system. As we discover more exoplanets orbiting distant stars, the lessons learned from studying Europa will inform our understanding of potentially habitable worlds throughout the galaxy. If life can exist in the cold, dark oceans of an icy moon, it opens up a vast new category of potentially habitable environments in the universe. Moreover, the technologies and techniques developed for Europa Clipper will pave the way for future exploration of other ocean worlds in our solar system, such as Saturn's moon Enceladus or Neptune's Triton. Each of these worlds presents its own unique set of challenges and possibilities, and the knowledge gained from Europa Clipper will be invaluable in planning their exploration. As we await the first results from Europa Clipper, scientists and engineers are already dreaming of the next steps in our quest to understand the potential for life in the cosmos. Whether or not we find evidence of life on Europa, the mission is sure to revolutionize our understanding of icy worlds and expand our conception of where life might exist in the universe. The Europa Clipper mission represents a pivotal moment in the search for life beyond Earth. As the spacecraft embarks on its long journey to Jupiter's icy moon, it carries with it the hopes and dreams of scientists and explorers who have long wondered about the possibilities lurking beneath Europa's frozen surface. Whatever discoveries await us, one thing is certain: the Europa Clipper mission will forever change our understanding of our place in the cosmos. As we journey through the cosmos with the Europa Clipper mission, it's clear that we are on the brink of extraordinary discoveries. The potential for life beneath Europa's icy shell captivates our imagination and challenges our understanding of where life can thrive. With its advanced instruments poised to analyze the moon's surface and subsurface, Europa Clipper is set to provide insights that could redefine our search for extraterrestrial life. The mission not only aims to confirm the existence of a subsurface ocean but also to explore the chemical ingredients necessary for life as we know it. Each flyby will bring us closer to answering profound questions about habitability in our solar system and beyond. The findings from this mission could pave the way for future explorations, perhaps leading to landers or even underwater probes that could directly sample Europa's ocean. Thank you for joining us on this fascinating journey into the depths of space and science. If you enjoyed this exploration of Europa Clipper and its groundbreaking mission, consider subscribing to our channel for more captivating content about the mysteries of our universe. Your support helps us continue to share these incredible stories and discoveries. Stay curious, and remember, the universe is full of wonders waiting to be uncovered. Until next time, keep looking up. Thanks for watching. Remember to like, subscribe, comment, share and click that notification bell so you never miss out. See you next week.